All right, let's do another question where we're gonna practice loops again. So if we start looking at the output, that's the output we have here. Um, we're gonna compute the factorial, right? This is the expression of the factorial, and factorial equal multiply all the numbers between n and 1, n minus 2 times 2 times 1, right? So n factorial is multiply all the numbers between 1 and n. Get all of these, multiply all together, which is obviously going to be a big number. That's why 5 factorial is 120. We're multiplying a bunch of times. So the first thing we're going to do before we solve this whole problem is we're going to solve the factorial only. So we're going to take care of this one thing only, and then we put the whole program together. So let's think about this guy. How about we look at here to analyze this question? If I want to compute n factorial, then I need to generate all the numbers between 1 and n. 1, 2, 3, 4, up to n. Generate all of these and multiply all of them together. So, alright, this is our empty program. Let's make sure everything's good. Program launches. Alright, let's write a bunch of code. So, we want to compute n factorial. We want the counter to generate all the numbers between 1 and n, right? We need every one of these between 1 and n, so counter is gonna do that in a for loop. And let's compute the result. I'm gonna make the result unsigned long int because it can grow very quickly. Result. Alright, so this is our loop for counter equal 1, counter less equal n, counter plus plus. So this setup here, the counter is gonna traverse all these values, and we need to multiply. This is called accumulation. So all the multiplication is accumulating in the result. Result equal result times counter, right? So I'm always multiplying by result, accumulating, and that guy is going 1, 2, 3 up to n, right? This is going up and accumulating. So you can obviously see here that result should be initialized to 1. We don't want to do 0 obviously because we will stay at 0. So result will initialize to 1, and we keep accumulating the multiplication, so this will be the right way. So that's pretty much it for factorial. This will compute the factorial. If you like to write the shortcut, result times equal counter, that's the same thing, right? Result times equal counter. There's only one line in the for loop, no need for brackets. Let's make this a program. So printf enter integer scanf %d ampersand n, initialize result to 1, loop all over the values between 1 and n, multiply them. We're done with the for loop. Let's print factorial %d equal %llu. That's unsigned long int %llu. So %llu result. Alright, I think this should run fine, so let's just double check very quickly. User input goes here, counter goes here, result goes here. Grab the user input, initialize the result to 1, iterate all the values, accumulate, multiply them, print the result. Let's run this. Factorial 3. Okay, that didn't go well. Factorial 3. Why is it saying 6 here? Let's see what we did wrong. Oh, here I'm printing factorial of n is result. So I forgot to put n. Factorial of n is result. Let's print. Alright, much better. Factorial 3 is 6. Good. Let's start again. Factorial 5, 120. That's good. Factorial 0 is 1. That's actually correct. By definition, factorial of 0 is 1. Why? How did that code produce the correct result? If n is equal to 0, what's gonna happen? If n is equal to 0, counter is 1, and the condition counter less than 0, which will be false initially, and the loop won't even start, and that's why we get result 1. So if n equal to 0, this loop will not even start. That's why the result stays 1 and prints 1, which is the correct operation. So it works for 0. What do you think is going to happen for the negative? I think for the negative, it will also be the same. Imagine if you have a negative number here, you start at 1, this is negative, the loop won't start neither. But we're not supposed to try it. You can even add a condition. If it's negative, don't even try anything, just print invalid. But let's make sure. Negative 9. Yeah, the loop won't start. We'll print 1. So what's the conclusion that we can make from this code so far is that if I want to compute a factorial, right, that's what it does. It does only one of these, not all. If I want to compute a factorial, I need to do a for loop. For loop, one for loop will do a factorial. If I want to compute factorial of multiple numbers, that means I need to run the for loop to do this. I need to run the for loop to do this, and a bunch of other factorials, right? Again, each factorial is gonna do for loop. So we can easily see that the inner loop, the inner part of the problem, the inner loop is a for loop. What's the outer loop? The outer loop is taking the number, enter integer, enter integer, enter integer. That's the outer loop, which is sentinel controlled. And each time you enter, you grab an integer, you run the for loop to compute the factorial. So what I see here is a while loop inside a for loop. That's the structure of the program. So let's see how we can adapt this. The nice thing is we have this code already. So what I'm thinking is I need to take this guy and wrap it in a loop, right? This should be the inner loop. This should be the inner loop. And this should be the inner loop, right? So if I take these guys, become the inner loop, I need to wrap them with the outer loop, which is looking for n not equal to -1. So that's n is a sentinel. So let's do this here. While n not equal than -1, do this from here to here. Right? So a couple things. How do you make sure the loop starts? This n should be initialized. So n equals 0. Let me do this here on a line. N equals 0. Non-sentinel, so the loop starts. So this will make sure the loop will start. Alright, let's trace this. Let's trace this. So once the loop starts, it's gonna say enter integer. We scan it, that's the scanf. We compute and we print. So this should work fine, except for a couple things. -2, if the input is negative, we need to print invalid input, right? So we need to take care of this here, because -2, if that's entered, it's gonna run through this and print a result. So we don't want to do this. And if -1, we don't want to print anything. That's where the program terminates, right? So there are two cases. Sentinel, don't print anything. Other negative numbers say invalid input, because factorial is not defined on these. So how do we take care of this? We need to do if on the if statement on the n. So let's say this again. Process legitimate input only if n greater equals 0, then process it. This is the processing. Processing. Just run the for loop and print. Else, if n is negative, is less equal than -1, that means -2, -3, then we print invalid input. Invalid input. Maybe invalid input. And so that's one case where we process. That's where we print invalid input. Otherwise, if it's -1, it's not gonna do anything, right? That's positive, that's less than -1. So it's -1, it won't do anything. And that will be already good enough. Alright, let's look at this again, see how it's gonna work. We're gonna make sure it accomplishes this output. So waiting for Sentinel. That's good for the outer loop. Initialize, so we start. Now grab the input, print and scan. Now couple cases. If we should process like the 5 and the 3, clear the result to 1, run the loop, multiply, accumulate, print the result. For negatives like this, print invalid input. For Sentinel, neither this nor that will be done. We go here and the loop terminates. So I think this is fair enough for this. Let's run it at this point. Compiles and runs 3. Yeah, we need the space here. Need to figure out to add the space. Let's do this. Where should I add the space? So after the scanf and we print the result, let's see, that's the end of the loop. Let's put the space here, right before the loop goes back to start again. Factorial 3 is 6, factorial 4 is 24, factorial 5 120, factorial -8, very good, invalid input. Let's trace this here. Factorial -8, we are here, we got -8. This won't be good, but this will be good. Print here, back to the start, ask again. Okay, so that works. -9, -10, factorial 7. You can see that the factorial grows very quickly, right? Let's do 6. So factorial 5 is 100, factorial 6 is 700, factorial 7 is 5000. That's why we needed unsigned long int. It grows really quickly. What about factorial 10? Already a really big number. Alright, factorial -1. Oh, that's a problem. Factorial -1, it printed something. We didn't need to print anything. And I can see the reason, because I should have done strictly less. Right? So strictly less, which means -8, -9, -2. Let's do this again. 3, 4, -2, -6, factorial 2, -1. Good. Program terminated. and we didn't have any more output, just like here. Alright, so that would be it for this question.